Alright, so in the instructions it tells us to round A and B to the nearest hundredths, and C should reflect the table values. So first, sketch an image of each of the following types of graphs. So linear is exactly what it says, it's a line, right? It can either be positive or it can be negative. Exponential is a curve, and again, it can either be growth or it can be decay. And then logistic is more of an S shape. Alright. Rip Van Winkle's beard grows longer the more he sleeps. Use the following table to answer the questions below. This data can be modeled with we have a table, so we're going to go and we're going to put it in stat. You type your X values are on top and your Y values are on the bottom. So we have 0, 1, 6, 10, 16, and in the Y we have 3, 5, 16, 22, and 35. The first thing we're going to do is we're going to look at it. And to look at it, you click Y equals, and you make sure that your plot 1 is on. So Y equals, plot 1 highlighted, and then you click zoom 9. This will help you look at the graph and see what shape it is. Zoom 9. So looking at this, I'm going to guess that it's a straight line. But just to make sure, we can go to Mode and turn our Stat Diagnostics on. So for this test, you're going to be looking at either linear, exponential, or logistic. So if I do Stat right, and then 4 for linear, I get 0.9966. If I do it for exponential, I get 0.93. So yes, it is linear. So linear is 4, exponential is 0, and logistic is B. So stat, go to the right, and we're going to be doing 4, linear regression. We're going to go ahead and store the equation right here by clicking alpha and then trace. Enter. This will put the entire equation into Y1 for us. Alright, so it can best be modeled by a linear regression equation. Write the appropriate regression equation. So it would be Y equals, my A value is 2.12, because the 1 would round up, X plus 1.37. If Rip has been asleep 20 years, predict the length of his beard. So this is where storing it is going to help us. If we go to second graph, we can see after 20 years how long his beard is. So after 20 years, it is 43.74 inches. And I know that it's inches looking here at my Y table. If Rip Beards measures 29 inches, about how long has he been asleep? So now I'm looking for 29 here in the Y. So it's going to be between 13 and 14 years. The rate of consumption of frozen pizza in the United States is shown in the table below. Use this information to complete the table and answer the following questions. This data can be modeled with so we have a new table, so we're going to go to Stat and enter in our new points. You can clear them out by going up at the very top, hitting clear, going down. Alright, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1.1, 1.5, 2.2, 3.2, 4.7, 6.9, 10.1, 14.8, 21.8, 32.1, and 47.1. Alright, we're going to look at the graph first. So if you check by going to Y equals, right, the plot 1 is still highlighted. So we click zoom and 9. Looking at that, that's very clearly exponential. So for exponential, we click Stat, go to the right, and 0, exponential regression. We're going to go ahead and store it. Click Alpha, Trace, and we're going to store it in Y1. So my equation to the hundredths place is y equals 1.04 times 1.46 to the x. About how many frozen pizzas were consumed in 1995? So if this is 1990, and it's the year since 1990, 1995 would be 5 years later. So according to the table, it's 6.9, but this says according to the regression equation. So that's looking at our table in the calculator. So after 5 years, 6.96. 6.96 thousand. So right here, 6.9, we would have gotten it right, but we would have lost a point because we didn't have it out to the hundredths place. About how many frozen pizzas would you predict would be consumed in 2030? Okay, so 1990 to 2030, if you don't know how to do the years, you just subtract what it says, and that's 40 years. So looking at our table again, you can jump by doing second window, and we're going to jump to 40, second graph. And again, if you scroll over, you can see the entire decimal here at the bottom. So how many frozen pizzas would you predict would be consumed in 2030? 4086421.94 thousand. Perfect. All right, the following chart shows percentage of a battery remaining over time. Use the table to answer the following questions. So we have a new table. So going to Stat, I'm going to clear this out. Clear out my equation in Y1. And we're going to type in our new points. Again, the top is the X, the bottom is the Y. 0, 40, 178, 265, 350. 100, 91, 55, 33, and 12. Go to Y equals. Plot 1 is still highlighted, so zoom 9. Looking at this, this looks linear, right? Because it is a straight line. So Stat, right, and we're going to do 4 for linear regression. We're going to store it by doing alpha, trace, and we'll calculate the equation. So y equals negative 0.25x plus 100.42. And you can see that that r value is negative 0.999916. Make a prediction about when the battery will run out. So that means when our y value is 0. So second graph. Let's see, so at 350 we're at 12. Let's do second window and jump to 500. Nope, too far. Let's go to 400. Nope, we're close. So it's going to be between 396 and 397. Nope. Minutes. Because in between there, it'll reach a 0. According to the regression equation, what percent battery will you have at 200 minutes? So to jump to 200, we do second window. Let's go to 200, second graph. And at 200 minutes, approximately, going over 49.74%. A student overheard the principal saying that there would be a fire drill at the end of the day. The following chart shows how quickly the rumor traveled. We've got a new table. We're going to put it in steps. Clear this out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My y values, 1, 3, 8, 20, 45, 87, 134, 169, 187, 195, 198. Ooh. Perfect. All right, we're going to look at it. So I go to y equals. Plot 1 is still highlighted. Zoom 9. That is S-shaped, so this is logistic. So here I do stat, right, and we're going to go to B. Again, I'm going to store it, alpha trace, and we're going to put it in Y1. So my A is 168.79, my B is 0.97, and my C is 200.12. So when I'm writing my equation, y equals, the C goes on top, 200.12, 1 plus my A value is 168.79, e to the negative 0.97x. According to the regression equation, how many students have heard the rumor in 11 minutes? So, second window, if I go to 11, 199.36. Well, you can't have 0.36 students, so we would say approximately 199 students, because that would round down. Use the regression equation about how long did it take for 50 students to hear about the rumor. So we're looking to see, when did this number get to 50? Between 4 and 5 is when it would get to 50. What is the limit to growth? So the limit to growth is the C value, which is that 200.12. And what does this mean? At most, 200 students will hear the rumor. What is inflection? So here we have the formula, the natural log of A over B, and then C over 2. So if I plug in my values, if I take the natural log, it's right down here next to the 4, the natural log of A, which was 168.79, divided by B, 0.97, I get 5.29, comma, and then 200.12 divided by 2, 100.06. So what relevance does this point have to the problem? After about 5 minutes, 100 students, which is half of the max, has heard the rumor and it will continue to spread at a slower rate. Because that's what happens at that point of inflection. It's reached half of its potential and the growth rate starts to slow down. The population of deer in Johnson State Park after T years can be modeled by this function. What's the initial population of deer? So we have a formula for the initial population, which is C over 1 plus A. Or You can also put this in y equals and just go to where x is 0. Either way. So we're going to do both. All right, so this is my C, this is my A, this is my B. So A equals 80, B equals 0.6, and C equals 1500. So if I was to take the 1500 divided by 1 plus 80, I would get 18.52. All right. If I go and I put it in y equals, I'm going to do alpha y equals to get the fraction. I'll put the 1500 on top. 1 plus 80. E, that's right down here. Do second E to the negative 0.6x. All right, so the equation should look exactly the same. Second graph, at 0, we get 18.52. I'm going to assume this is in thousands. It really doesn't say, but I'm going to go ahead and keep the 0.52. But if it's actually just talking about there's a flat 19 deer, then we would have to round it to the reasonable. So you may want to say 19 if rounded. Okay, how many deer were in the park in 8 years? So after 8 years, 904.5. Again, if rounded, we would say, honestly, that's less than 904.497, less than half, so it'd be 904 if rounded. After how many years will the deer population reach 800? So it's going to be somewhere between 7 and 8 years. What's the maximum number of deer that Johnson State Park can accommodate? That would be that C value, the 1500. All right. A road intersection was built and the following data was collected. So I'm going to turn this into a table. In the 5th month, 350 vehicles passed through the intersection. In the 19th month, 600 vehicles passed through the intersection. In the 23rd month, 750 passed. 26th, 850 passed. 33rd, 950 passed. And we're going to write it for each of the different types of functions we've been talking about. So I'm going to clear this out. 5, 19, 23, 26, 33. 350, 600, 750, 850, 950. So they want it for each of them. I want to look at it and just see which one I think would be best. So if I hit zoom 9, I'm going to guess logistic based off of that curve, okay? But really, we're just plotting it for each of the different ones. So stat, right, and we're going to linear first. Y equals 22 point, the 6 would round the 9 up, which would round the 2 to a 3, x plus 227.31. And it's 0.9889 for strength. Stat right, now we're doing exponential, which is 0. Y equals 298. Actually, the 99 would round up, so it would be 299 times 1.04 to the x, and it's 0.9872. And then logistic, we'd get y equals, my C goes on top, 1369.57 over 1 plus My A is 4.34 e to the negative 0.07x. So we've used the same points. We've done linear, exponential, and logistic. And based off our model with the S value, logistic would be the best fit.